So before we start with the presentation of the product, just let me make a short introduction of the Screening Eagle technologies. The company was created through the merger of DreamLab in Singapore and Proceq in Switzerland, with the mission to protect the built world with software, sensors, and data. Screening Eagle's full-stack inspection solution combines intuitive software and powerful portable sensors to deliver reliable data for construction and asset management decisions. We are on a steep growth path to realizing this vision of a predictive healthcare that extends asset life and increases long-term value for asset owners. This is the overview of the seminar. So we will try, first of all, to make a short introduction of the product, and then we will discuss briefly about the sensor, the software, the technology, and lastly, but not least, we will discuss about the offer, the prices that we actually sell the product, and how you can buy it. Every year, about 22 billion of new concrete is being used for new structures. So getting to know what is happening with this concrete is essential, and thus concrete inspection is required during several phases of construction, or even a number of years after its completion. As you can imagine, concrete inspection takes time, especially when you deal with large areas. Or to rephrase that, it used to take time until today. Why we need to scan the concrete, why it's so necessary. The problem with the concrete when we want to either assess it, or if we want to make an extension, or if we want to renovate something, is that we have to drill a hole inside the concrete to do that work. So it's estimated that about 50 billion holes are drilled in concrete per year. That's a huge number. Just imagine what can happen if you drill on the wrong spot. One small mistake on the site can actually get you with a costly damage, or even worse, liability. So what's our proposition? When it comes to large areas, we have realized that single sensors, ground penetrating radars, do not work that well because they need so much time to gather the data that you need. So we came up with a GP8100, which is a multi-line ground penetrating radar sensor. So this actually offers you ultimate productivity, easy object detection, and of course, unmatched data intensity. Let's say a bit about the unit and how it works, how it connects to the world. So let me highlight a bit parts of the screen. This is the sensor. This is the basic hardware, the ground penetrating radar, with 6 different antennas located side by side, each to the other. And this sensor communicates with an iPad that runs the GP software. As you can see, the sensor, it has a main handle over here in the center and 2 grips on the sides. So the GP8100 is a powerful tool to increase productivity. It actually gives you the option to scan 6 times faster than regular ground penetrating radar devices. So you save time and money on site. Both of these are very important when you're a contractor or when you have a company that makes concrete inspections. If you look over here down below, you will see the backside of the GP8100. You will see the antennas, And because of the technology, we can go deep down to about 80 centimeters, which is very unique for this type of arrays. And on the same time, we can scan a width of 25 centimeters with a single pass. And that's also very innovative as well. The GP8100 offers you also something really new. You can detect items below the surface of the concrete with easiness. If you have any experience with any ground penetrating radar in the past, you may remember or you may have experienced that ground penetrating radar data is not the easiest thing you can deal with. It comes with a number of obstacles, and also it requires some experience from the user to understand what he sees on the screen. With the 8100, we actually overcome this burden because with a single pass, you can now see superlines, as we call them. That means you don't see any more hyperbolas. You see a line forming from the target that's below the surface of the concrete. This picture over here is actually showing a GP8100 that's scanning this way. And then you have targets both in the parallel and the vertical direction. When you scan this way, the GP8100 will actually display on the screen immediately and with no post-processing the line that's vertical on your direction, on your movement. No more hyperbolas. You see the line forming and you have a clear view of what's happening below the surface of the concrete. So it's not only about easiness, but it's also about increased confidence. You don't deal with multiple hyperbolas. You don't deal with false hyperbolas. You don't deal with mirroring of data. Whatever it is, it shows as a line, and you know where it is, the depth, and even its direction. Another important factor of the GP8100 is the ability to scan at a very high scan rate. As we said before, the GP8100 is actually comprised of 6 independent antennas. And I'm highlighting the independent because each of these antennas can collect up to 200 scans per second. And altogether, they can collect 1,200 scans per second without any compromise when they all work together. So you can scan very big areas, very large areas, and still get a very high resolution. So with the GP8100, you get very dense ground penetrating radar data, even at a very high speed. And that's really, really nice. So the accuracy of your survey is very high, and the effectiveness of your time spent on the field is also very high. Let's talk a bit about the ergonomics. So what you see over here is a top view of the GP8100. And you can see that in the middle, you have this nice handle. That's actually the main handle. And on the back of it, you have the flight-ready battery pack, which uses standard AA batteries. Why we insist on AA batteries? Because it's very easy to transport these batteries. It's very easy to ship the equipment without any specific regulations or without any special cargos. And for example, for lithium-ion batteries, it's getting harder and harder to ship batteries nowadays. Also, wherever you move to do your survey, you can rely that you will find AA batteries because they are everywhere. On the left side from the handle, there are 2 insert holes. One is for the telescopic handle holder over here, and the other is for the tablet holder over there. So if you buy the accessories for the telescopic hand. You can insert it over here, and then you can scan areas like floors with easiness without the need to kneel. And here you can have your tablet and you can see your data as fast as you can collect them. Let's discuss a bit about the how this thing is being made. So the chassis is made out of magnesium. That's a very durable material that gives you confidence on the field that you can use it without any significant wear on the unit itself. It also comes with a durable underbody, so no matter how rough the concrete surface is, you can still collect data without damaging your antennas. The whole construction is very rugged and very easy to use. The other parts of the GP8100 are the wheels. You have 4 wheels. You have the wheel encoder that actually triggers the data collection and also gives you the location for the x-axis when you move your ground penetrating radar. You have lasers on the front side and on the left and right sides, so you can easily mark the targets in case you do a scan and locate job on the side. We also have a built-in live wire detection, so you can detect live wires. And something that came out of popular demand is a USB-C connector on the back of the unit. And this plays a dual role. One is for the power bank in case that you need more battery autonomy for your work. So you can connect the power bank and you can work for a number of extra hours as long as you need it. But also, in case you work in restricted, Wi-Fi restricted areas, you can connect your iPad through the USB-C connector and collect the data from the GPR unit. That's the backside of the GP8100. You can see that the antennas are being separated by lines. And on the top of these lines, you can see LED lights. So that makes it easier for you to mark where the targets are. And the whole design is made in order to make your marking on concrete easier for the user. Let's talk a bit about the specs. So the GP8100 is the newest addition to the GP series of Screening Eagle Technologies ground penetrating radars. And as you may know, or if it's the first time that you hear it, we are using the stepped frequency continuous wave ground penetrating radar technology. I will discuss a bit more detail in later slides about the technology and what advantages it brings. But overall, this stepped frequency continuous wave gives you a very wide bandwidth. So for example, for this unit, we have an ultra wide bandwidth of 400 up to 4,000 megahertz, which is really very important when you work on the concrete. The connection capabilities of the unit are mainly the Wi-Fi that connects the GPR with your iPad. And as we said before, for Wi-Fi restricted areas, you can use a USB-C connection. The maximum penetration depth that you can get with the unit is down to 80 centimeters. And it's by far the deepest penetration you can get from a concrete GPR in the market at this moment. The effective scan width is 25 centimeters, And the most important is the line spacing of 5 centimeters. I will explain you later on why this is important. Scan rate, as we said before, it's 1,200 scans per second. So the unit is capable of collecting data very, very fast. The distance of the antenna to the edge is 8.3 centimeters. So that means that you can get very quite close to narrow areas or edges. And weight and dimensions are just given below in case you need them. So let's talk a bit about the software, because the software is actually the brains of our system. The ground penetrating radar, the GP series, is actually coming along with the GP software. So the GP software is an iOS application that you can download and you can even play now, even if you don't own the equipment, since we also provide sample data. So the GP application is the core, but we are also offering to our customers or anyone who has a Screening Eagle ID, we are offering the Workspace. Let's discuss a bit about the Workspace and what it offers. So Workspace is a platform that's operating system agnostic. That means that you can get into this platform no matter what computer or tablet you are using. You can use a PC, you can use a Mac, you can use any Android tablet, and still you can have access to this platform. All you need is your Screening Eagle ID, and then you can connect to your account and you can have access to your data or to your folders or to the data that others may share with you. So this platform, as I said, gives access to data that you have collected, so you can upload your data in there. But more importantly, it gives you the ability to cooperate, to collaborate with other people by sharing files, by sharing screenshots or other information critical for your work. The GP application, it has a history of version updates. So it started around 2017, and from this time up to today, we came up with a number of updates, and each time the software was getting better and better. Right now, we are at version 5, which covers most of the abilities for the new GP8100. So let's discuss about the software, what you get more with the GP8100. As you can see over here, this is your iPad, and this is a screenshot, a video, while you're collecting data on real time. And that's really amazing because you don't see any hyperbolas, you see lines. You are moving your ground penetrating radar and you see these vertical targets forming into your iPad, which is really amazing. And by playing with the thickness size over here, you can see other targets that are probably deeper or shallower. So this is the data collection, means that you are moving forward, and this is moving backwards. So it's a playback version more or less, so you can go and mark or annotate your targets. So you get your targets in a clear way and visibly while scanning. So that's very, very important. Here's a video just show you how fast you can collect data. Hussam over here is using the telescopic rod. So he collects data at a very fast pace, and you can see how data is forming on the screen of the iPad on real time. So let's discuss a bit about the superline scan. You have 6 antennas, as we said, and you can get the lines. of the targets that are crossing perpendicularly to the direction that you're moving your ground penetrating radar. So right now with the GP8100, the marking of linear objects is very easy and very precise. It has never been that easy and precise in the past. We also offer the split view, and that's very important for those who are into coring or drilling. So what happens with the split view? So the split view, as the name says, splits your screen into two different parts. So you have the superline part over here on the top of the screen, and then you have the raw data, the raw ground penetrating data down below. So with this view, you can actually verify which is the best spot for you to drill a hole into your concrete. And by playing with your thickness, the depth, you can verify whether you have any other targets, either deeper or shallower from the spot that you're seeing right now on the screen. So drilling is becoming very, very accurate. And this increases the confidence of people who work in the industry. So what we have seen up to now is the 2D scan, okay? But this unit is also capable of collecting data in 3D mode, an area scan, as we say. So you can collect data every 30 centimeters. We have grades that are made that are 1 by 1 meter. So you can collect data every 30 centimeters. But the most important is that you only need 30 centimeters spacing for a single line. But the resolution is very high. Remember, the spacing between the antennas is 5 centimeters. So your resolution remains 5 centimeters. That means very high. But you only need to cover 30 centimeters, a single pass with your unit. That means that you cover an area at least 6 times faster than single line ground penetrating radar units, and your resolution is better than a single GPR unit. Another thing that we are offering, because we had in the back of our mind those people who want to scan large areas, we offer you flexible grids up to 100 square meters. As you can see over here, you can select your grid and you can collect your data, even if it's 100 square meter. That's a number that is very big. It's almost unbelievable for people who work in ground penetrating radar. So productivity gets far better. And this is how a 3D data looks like. And with the app, you can actually zoom in, zoom out, you can rotate, you can color annotate the different slices, the different depth size, so you can see your targets way more clear than having all the targets with the same color. And you can also display that with augmented reality and many, many more things. One of the most important things of the GP software is that it gives you the option to start a scan, and then if something happens, if you need to take a break, or if you want to resume next day your scanning, you can still do that. So with our software, we can start a line or we can start an area scan. And then if we see that we don't have enough time, or if we want to take a break, we can pause the scan data collection, and then we can resume from the point that we have stopped. And that's very important, again, for people who work in large areas, large concrete scanning. So I will give the floor now to Hussam, who can tell a bit more about the features and the upgrades of the software.
Thank you, Michael, and good presentation of the software. So guys, here, that's very important to mention that we have already developed many features the last 3 years, and we continuously keep developing, updating it and improving it in our pro subscription offer for any sensor. So the previous sensors in the GP series, and also the last one that we present today, the Proceq GP8100. And good to remind this wonderful, file cloud export, all this collaboration. Workspace is a new one, but also you can export CGY and snapshot and HTML, or share the measurement file via URL. That's very important for you, for any inspector, contractor, or engineer. The power here of the iPad, has been used properly, and we can now scan up to 100 square meters. Of course, with the GP8100 sensors, more adapted for that application. And you can also tag, remove the background, the noise on the surface, and you can also optimize for experts with the hyperbola fitting to be close, to the materials to get good data. Michael, next slide.
Yes.
And of course, the display here is really the terrific features. As Michael mentioned, we have the sliders. You can travel across the thickness in what we call time slice view, and you can also have it on the superline scan for the GP8100 sensor. You have the live wire detection, good to detect the wires, and very important to remind that in the field immediately you can have the 3D view, augmented reality as well, 3D augmented reality, and the color depth indication. That's really many features that customers want to have in the field. They don't need to go to the office and post-process the PC, 1 hour to get first views like this. Here with your iPad is sufficient enough, powerful to do that. Annotations also are there. And we have, as new features, as mentioned by Michael, the resume iris scan, which is, we've heard the feedback of customers. Many of you like to pause because it's a longer process to scan, 2 hours, 3 hours, and then you would like to have a meeting or a pause break sandwich. You can do that today with the resume iris scan. And the super and scan split view, as mentioned by Michael, only available with the GP8100 sensor. Wonderful features to be very precise and to detect objects very quickly for non-experts. And we keep developing it. Every 6 months, 5 months, we come up with new features. That's the advantage here with the pro subscription offer. In summary, on the sensor, the Proceq GP8100, with in combo with the software GP app, you have a huge productivity gain, data density never seen before, for a handheld GPR device, raw data quality exceptional. The interpretation, again, for non-expert becomes very easy. So if you're a technician, any contractor or engineer not familiar with GPR technology, you can in one scan see the object directly. An expert can use that properly, for the data density and really post-process the data after. The applications for the different sensors, you have first, as a reminder, the GP88. Very successful in the building areas, congested areas, close to the column, edges, or the curved surfaces, like the column that we've seen in the movie here, the handy size. Then you have the GP8000, a very solid one, combining, data clarity and a good ergonomics. Many of our customers, they use that in tunnels or bridge, when they have 800 meters, 500 meters of long line scan. That's the perfect tool for that. Very appreciated on this level. And then with the new one, the new sensor, you have an ultimate productivity here for large, you can imagine large slabs, areas, or when you want to scan quickly, easy object detection for non-expert. That's the perfect tool here, the GP8100. So find the right solution for your needs here.
Thank you very much, Sam. So let's discuss about the technology. So as I have already mentioned in the specs, the GP8100 is using the technology that has already been introduced in the first GPs in 2017. And this is a stepped frequency continuous wave technology. Now let's try to compare that with what has been in the market for years. So in the past, the majority of ground penetrating radars were using the pulse technology, and this technology has certain limitations, which I would say the most major limitation is actually the frequency dilemma. So what happens over here is that you are buying a specific ground penetrating radar based on the antenna and based on the application that you would like to apply the certain frequency. That means you need to make a compromise between the depth penetration that the antenna provides you and the horizontal resolution. So the rule of thumb over here is that when you buy something that has lower frequency, you can penetrate deeper. For example, over here, you can see that. You can penetrate deeper, but the result, the object that you are seeing has to be a bit larger compared to the other ones. And the horizontal resolutions, that means the resolution that you are seeing things in the horizontal way is worse as you are lowering the frequency. On the other hand, when you increase the frequency, you get better resolution, but your depth penetration is limited. So always a customer had to choose between resolution and depth penetration. This is being solved by the step frequency continuous wave technology, where you have a very wide bandwidth. So in our case, for the GP8100, we have a bandwidth from starting from 400 megahertz up to 4 gigahertz, meaning that you get enough depth penetration to see inside the concrete, but also you get very high resolution in terms of horizontal resolution and of course detecting smaller objects. This is a slide that we decided to put into this webinar because we have seen that many people are confusing two different terms. One is the regulation and the other is the standards. So let's try to clarify that a bit. When we are saying regulations, we mean all these set of rules that are being set by authorities and that put specific, let's say, limits or limitations to what you can emit, because a ground penetrating radar emits electromagnetic wave, so it has to be regulated. Our units are actually complying with the major regulations and major regulation standards, although I didn't want to use the word standards. So our units are compatible with FCC and CE, which are very important in case you would like to move your unit out of your country and go to another one for a job. So in most of the cases, you will need to be compliant with these regulations. When it comes to standards, it's a bit different though. It's not related to emissions or any controlled by the state or by organization limitation of what you are emitting. When we are saying standards, we are describing a methodology. So in terms to have a uniform methodology for the non-destructive testing, a number of organizations have established some standards where they describe the optimal methodology to collect and process the data and how to build a report out of it. So in terms of not having different methodologies or to misinterpret data or to have a specific GPR dataset being interpreted this way in this country and in another way in another country, several organizations have set up standards for GPR scanning, either for concrete or for utilities or for other applications like roads, for example. So you have the AESTM standards, the AESTO standards, and so on, okay? So we would like to clarify that because we see that many of our customers are confusing those two things, although they are very different. So Hussam, again on you.
Yes, we are talking now about GPR technology, but as an inspector or contractor engineer, you know, when you want to inspect any concrete structure, that's important to remind here that we cannot do it only with one technology like GPR, which we developed recently, and we give good results. I think the market appreciates all customers. But here, a fresh reminder that eddy current testing was our first technology to develop, you know, in the 70s and the 80s, and we launched the Performeter family. Eddy current technology is very important to estimate the rebar diameter and concrete cover, and also ultrasound that we developed in early 2010s, and today with the Pondit family. Then I will show you why it's so important to have the three technologies here. Why? Because let's take an example of a piece of concrete, you know, made of rebars and also defects, objects, pipes, and of course the end of the piece of structure, the back wall, what we call it, or it's basically the thickness, the main dimension on the thickness. So with the Performeter family and the current technology, you're only able to actually, you're very shallow, very precise, but very shallow, not more than 10, 12, 15 centimeters, depends on the conditions. But here you will only be very precise to locate the rebars, only metal, to estimate the diameter of the rebar, and of course the concrete cover, which is very important, okay, in civil engineering, structural engineering, and for the durability of structure. But you stop here. Then if you want to map, to have the skeleton, the layout, GPR here is perfect to map the layout of any object inside, like the metal, not only the metal, but also any object like plastic. You can also detect that. And also the back wall, you can have some thickness, but you limit it to 80 centimeters, which is very good already. But then to complete all those different technology, you need the ultrasound at the end if you want to detect defects like honeycombs, hidden crack where there is air. The ultrasound is really perfect here because you have 100% the wave will bounce back on the air, similarly to GPR for the metal. And here you go up to 2 meters for that. So that's really unmatched if you want to go further in terms of back wall and thickness. So you see here, there is no other way. You need all those three technologies that we already propose in our portfolio: Performeter family, Proceq, and Pondit Live Array. Here a summary. So rebars, you can approach that for the first and second layer rebars, cover diameter and corrosion. You can go with the Performeter family, the current technology. Then for the Proceq GPR, that's perfect also for the layout and the mapping, but also not only rebars, but also object. The Pondit then can help you also for object, but not like GPR's precise, but can go deep, as I said, 2 meters depth. That's exceptional also for that. the thickness as well. That's normally the ultrasound the way to go for the explanation that I gave before with the air. And the defect, there is no other way, only the ultrasound or the pounded array can do that. And we have many applications like the, unfortunately, the ungrouted post-tension tendons, which can give very catastrophic, sudden, accidents that we've seen before, unfortunately. And here, the pounded array is really good to detect those, air pocket ungrouted, and also good for steel fiber concrete when you have those pocket of air. So again, very complementary families here.
Thank you, Hussam. So what's the offer? What do you need in terms of money to buy this new technology? I believe it's a very fair price for what the unit offers. So we are giving the hardware for 3,950 Swiss francs, and that's a one-off purchase. And then every year you commit to pay 2,976 Swiss francs with a 2-year commitment for the software subscription. And this is very important. Some people are asking, why do I have to pay for a subscription? Well, the reason is that you're paying because you want to get the most updated software, because you need to get access to the newest things. And if there was no subscription, you would probably be limited to an initial version and a few software batches from time to time, and that's it. What happens right now with the in the market is that you are mainly buying the hardware and the software comes along, but you are not paying any value for the software because the software is not really updated substantially. What happens is that they find some bugs, they fix the bugs, and it's called an update. So on top of that, on top of this price, we offer for free the Workspace platform. And I think this platform is actually complementing the whole package of the GP8100, especially if you have partners or collaborators around the world, and you would like to share data with them without the need to use an iPad, okay? So that's important. What comes with the package? So when you are buying the GP8100 sensor kit, you get a rugged case, this one over here. It actually includes the hardware, the GPR hardware, the battery pack, a few extra batteries over here, the charger cables, some pads to collect area data, and the augmented reality sticker. There are a few accessories that you can buy as extras. So there's a tablet holder where you can, as you may remember, you can insert it into the hole on the left side of the GP8100, and you can have your iPad on the 8100. And this is a telescopic rod, ideal for people that are collecting floor data, and they have large areas that we like to scan with easiness and speed. So that's the end of the presentation. Thank you very much for attending.